Okay, here we go. So let's take a look first at what's called monatomic compounds. Okay, so our title today, let's start over. Our title today will be monatomic ionic bonding. Monatomic. Okay, real quick, if we just look at that word. If you had to break up this word and split it up, where would you break it up at? Mon, and then atomic. Yeah? So the prefix mon comes from mono, which means one, singular. Okay? So mono meaning one, atom, and then the suffix ic means pertaining to. So what we're talking about with monatomic ionic bonding is we're looking at formulas where there's only one element as our cation and one element as our anion. When we get to polyatomic in a few days, then we'll be looking at things that have more than one element. Okay, but today we're just looking at our main group representative elements, the A group, and we're looking at kind of things do they form. Okay, so we're going to start with the name to formula. So if you're given a name, how can you turn that into a formula? So for example, magnesium bromide is our example. Okay, well, magnesium sounds like magnesium, yes? So if we're going to turn this into a formula, the very first thing we would do, so number one, we're going to write the steps out as we do the example so we can connect it to the steps. So number one is write each element symbol and their charges. Write each element symbol and their charges. Okay, so for our example here of magnesium bromide, well, the first thing we do is write the element symbol. So magnesium's element symbol is Mg, capital M, lowercase g. And then bromide. That sounds like an element. Bromide sounds like bromine. So bromide is when you have a anion, the ending will change to "ide," and so you kind of have to think, all right, well, what is the root of that word and what element is that? So bromide is bromine, which is Br, and then we can write their charges. So magnesium is in group 2A, so because it's in group 2A, it has 2 valence electrons to give as a metal, so it's going to form a 2+ charge. And bromine is in group 7A, which means it has 7 valence electrons, and it needs 1 more to get to that 8 octet. So bromine will form a 1- charge. Step 2. Crisscross charges. And then number 3 goes with it. Reduce if needed. So you know in math how you can reduce? If you have 4x over 2, you can reduce the 4 over 2. It's the same idea, okay? So if I crisscross these charges, then turn to your neighbor and tell them what you would get. What would be the formula? So if I crisscross these charges, I would end up with MgBr2. So MgBr2 would be my formula from this name. So really, we already know how to do this. We learned how to do this last week. The new part is saying, well, how do I get this from a name? And the name just tells you what elements you're putting together. So instead of me saying, oh, you're going to combine aluminum and oxygen, you have aluminum oxide. It's just the name. Okay, one quick note that I want you to make, just a little star, is that the ending on the anion, meaning the negative one, changes to "ide" today. So chlorine becomes chloride, bromine becomes bromide, oxygen becomes oxide, sulfur becomes sulfide, and so on and so forth. The ending of the anion will change to "ide." Your cation is going to stay the same. Magnesium is still magnesium. Calcium will be calcium. But the ending on the anion will change. Okay. That's pretty straightforward, yeah? The only thing here that's really different is now we have an "ide" ending, okay? What I want you to do is skip a line and then count out 7. 1, 2, 3, 4, 5, 6, 7, and then draw another little line. We're going to leave this part blank on your paper, and the reason for that is when you get to practice, you're going to glue that in that blank spot, so that way you have a front and a back practice. You see what I'm saying? Yeah? We're making flippy homework practice notes. Okay? All right, this next part is the newer part. So now we have a formula. Let's say we're still looking at that MgBr2. If I give you that to start and I ask you split it up into ions, how do we do that? So we're basically going to uncrisscross before we form the compound, and now we're going to break it apart. So splitting the compound into ions. Okay, why is this important? Why do you need to do this? Well, when we get to chemical reactions and we start reacting compounds together and they make new combinations, we need to know how to make those new combinations. So we need to look at a formula of an ionic compound, be able to break it up so we can make new combinations. Okay? So we're going to write out the steps, and then we're going to do 3 examples. Okay? So number 1, let's just write the steps out first. Number 1, write each symbol separately. Write each symbol separately. Step 2, write the charge of each element. And then number 3, show how many of each ion is present. Okay, and we know how many are present because it comes from the subscript. So in parentheses, I'm going to write subscript here because that's how we know how many are there, is from the subscript. So show how many of each ion is present with a coefficient. Okay, what's a coefficient? Let's review. Turn to a neighbor, and in this example, tell them what the coefficient is. So the coefficient here is the 3, because the 3 is telling us how many x's there are. The x is the variable, yeah? So the 3 is the coefficient telling us how many x's there are. What if I said 3 Mg2 plus? How many Mg2 pluses are there? 3. So this coefficient tells us how many there are. And this number comes from the subscript. Because in the formula, isn't it the subscript that tells us how many there are? So it's the same idea. We're just pulling that out as a coefficient. So let's do some examples. In fact, here we go. Example Mg3 N2. Mg3 N2. All right, this is a compound. We're going to break it up back into the ions. Step 1, write each symbol separately. So I have 2 symbols here. I have magnesium, Mg, and I have nitrogen. And as an ion, it would be called nitride. Okay? That's step 1. Write each symbol separately. Step 2, write the charge of each element. Okay, well, we already know these. Magnesium is in group 2A, which means it has 2 valence electrons to give up, so it forms a 2+ charge. Where nitrogen is in group 5A, it's a nonmetal, and so because it has 5 valence electrons, it's looking to gain 3 more, so it will form a 3- charge. That was step 2. That's the part we already know how to do. 3, show how many of each ion is present, meaning it's coming from the subscript, as a coefficient. So in the compound, the Mg3, doesn't this 3 mean that I have 3 magnesiums? So over here with my ion, I have 3 Mg2 pluses. I'm pulling that subscript and putting it as a coefficient because that tells me how many there are. Same thing with this nitride. I've got 2 as my compound, so this 2 is telling me that I have 2 nitrogen ions. So I'm going to pull this out as a coefficient. So I have 3 Mg2 pluses, and I have 2 N3 minuses. So if I say I have how many total number of ions are there? Okay, well, let's take a look. If I were to just write this out, Mg2 plus, Mg2 plus, Mg2 plus, N3 minus, N3 minus. Okay? That's what this means, right? The 3 as the coefficient means that I have 1, 2, 3 magnesium ions. The 2 as the coefficient means I have 1, 2 nitrogen ions, nitride ions. So how many ions are there total? 1, 2, 3, 4, 5. So there are 5 ions in this compound. Turn to your neighbor and tell them where the 5 came from. So it's kind of like we're uncrisscrossing, right? Let's do another one. Here we go. AlBr3. We're going to split this up. Step 1, write each symbol separately. So that's aluminum. And then bromine, or bromide, is the name of the ion. 2, write the charge of each element. Okay, well, aluminum is in group 3A, and it's a metal, which means it has 3 valence electrons to give up. So when it gives up those 3 valence electrons, it forms a 3+ charge. Okay, well, bromine is in group 7A, which means it has 7 valence electrons, which means it needs 1 more to gain. So bromine forms a 1- charge. Okay, then step 3, show how many of each ion is present with a coefficient. Well, in this compound, how many aluminums are there? There's just 1. Is there a subscript here? So that means there's only 1 of them, right? So just like in math, do you have to write 1x? No. So we don't write the coefficient 1 because you wrote it. So that means that there must be at least one. But how many bromides are there?
3.
Okay, so this 3 as a subscript tells us that there are 3 bromide ions. Okay, so if I'm going to add together how many ions there are here total, 1 aluminum ion plus 3 bromide ions equals how many? 4. So there are 4 total ions here. Let's do one more, yeah? CaO. Try this one on your own for a second, and then we'll go over it. So split them up, write your charges, your coefficients, and how many ions are here total. Okay, CaO, step 1, write each symbol separately. Ca for calcium and O for oxygen. Number 2, write the charge of each element. Okay, calcium is in group 2A, which means it has 2 valence electrons to give up, so it forms a 2+ charge. Oxygen is in group 6A, which means that it has 6 valence electrons, and it needs 2 more to get to 8. So when it gains 2 electrons, it will have a 2- charge. 3, show how many each ion is present with a coefficient. Okay, well in our compound, there's no subscripts. So this tells me that it's a 1-to-1 ratio. So there's 1 calcium ion and there's 1 oxide ion. Okay, so do I write anything for coefficients? Nope, because it's only 1. So total number of ions then, well, there's 1 calcium ion and there's 1 oxide ion, so 1 plus 1 is 2. Thumbs up if you got that right. Awesome. Okay, so here's what you're going to do for your practice. I have this paper. The title is the Monatomic Ions Practice. You're going to end up gluing it down on the title. The front side is the top part of our notes, which was the name to formula. Okay, where you have your name, you write the cation. Remember, the cation is positive, the positive one. The anion is the negative one. And when you write your formula, you write the positive and then the negative in your formula. This is exactly like we were doing up here. Okay, it's exactly the same. This is really familiar too. The newish part, the one we just went over, is going to be what's under the flip here. Okay, so when you flip this up, then you have your notes for splitting the compound into ions and where you're going to do your practice. So the cation is the positive one, the anion is the negative one, and then your total number of ions. So this is exactly like the examples we just did. Okay, so you've got lots and lots of practice here, and we're going to spend the rest of the class period going over this.